Welcome. Today, we're diving into the fascinating world of deep learning. You might have heard the term tossed around in discussions about artificial intelligence, but what does it really mean? Deep learning is a subset of machine learning, which itself is a branch of artificial intelligence. It's all about teaching computers to learn from data in a way that mimics the human brain. In this video, we'll break down the basics, explore how deep learning works, and see why it's such a powerful tool in modern technology. Let's get started by understanding the roots of deep learning and how it fits into the broader AI landscape. To truly grasp deep learning, it's important to see where it sits in the world of artificial intelligence. Think of AI as the big umbrella, covering everything from simple rule-based systems to complex learning algorithms. Machine learning is a subset of AI, focusing on systems that can learn from data. Deep learning goes a step further, using structures called neural networks that are inspired by the human brain. These networks can automatically discover patterns in data, making them incredibly useful for tasks like image recognition, speech processing, and more. At the heart of deep learning are neural networks. These are computational models inspired by the way our brains work. A neural network is made up of layers of interconnected nodes, or neurons. Each neuron processes information and passes it on to the next layer. The more layers a network has, the deeper it is, hence the name deep learning. These networks can learn to recognize complex patterns in data, which is why they're so effective for tasks like recognizing faces in photos or understanding spoken language. So, how does deep learning actually learn? It all starts with data. The network is fed large amounts of data and adjusts its internal connections based on the patterns it finds. This process is called training. During training, the network makes predictions, compares them to the correct answers, and tweaks itself to get better over time. This cycle repeats until the network becomes highly accurate at its task. The more data and computational power you have, the better deep learning models can perform. A key feature of deep learning is its use of multiple layers. Each layer in a neural network extracts different features from the data. The first layers might pick up simple patterns, like edges in an image, while deeper layers recognize more complex structures, like shapes or even objects. This hierarchical approach allows deep learning models to understand data at multiple levels, making them incredibly powerful for tasks that require high-level understanding. Within each neuron, there's a special function called an activation function. This function decides whether a neuron should be activated or not based on the input it receives. Activation functions introduce nonlinearity into the network, allowing it to learn complex relationships in the data. Common activation functions include ReLU, sigmoid, and TON. Without these, neural networks would be limited to solving only simple problems. Training a deep neural network involves adjusting millions of parameters. This is done using algorithms like backpropagation and optimization techniques such as gradient descent. The network learns by minimizing the difference between its predictions and the actual answers. This process requires a lot of data and computational resources, but it's what allows deep learning models to achieve such impressive results. Backpropagation is the backbone of deep learning training. It's a method for updating the weights in a neural network by calculating how much each weight contributed to the error. The process works by moving backward through the network, layer by layer, adjusting the weights to reduce the overall error. This allows the network to learn from its mistakes and improve its performance over time. You might wonder why deep learning has become so popular in recent years. The answer lies in the combination of big data, powerful computers, and improved algorithms. With more data available than ever before and advances in hardware like GPUs, deep learning models can now be trained faster and more effectively. This has opened the door to breakthroughs in fields like computer vision, natural language processing, and beyond. One of the most well-known applications of deep learning is image recognition. Deep neural networks can analyze photos and identify objects, faces, or even emotions. This technology powers features like facial recognition in smartphones, automatic photo tagging on social media, and advanced medical imaging tools that help doctors diagnose diseases from scans. Deep learning also excels at understanding spoken language. Speech recognition systems use deep neural networks to convert audio signals into text. This technology is behind virtual assistants like Siri and Alexa, as well as real-time translation apps and automated customer service bots. The ability to process and understand human speech has transformed the way we interact with technology. Natural language processing, or NLP, is another area where deep learning shines. NLP models can understand, interpret, and generate human language. This technology is used in chatbots, language translation, sentiment analysis, and even content creation. Deep learning has made it possible for machines to understand context, sarcasm, and subtle nuances in language. Deep learning is a driving force behind autonomous vehicles. Self-driving cars use deep neural networks to process data from cameras, sensors, and radar. These networks help the car recognize objects, predict movements, and make decisions in real time. This technology is paving the way for safer, more efficient transportation systems. In healthcare, deep learning is revolutionizing diagnostics and treatment. Neural networks can analyze medical images, predict disease risks, and even assist in drug discovery. By learning from vast amounts of patient data, these models help doctors make more accurate diagnoses and develop personalized treatment plans. Ever wondered how Netflix suggests movies or Amazon recommends products? That's deep learning at work. Recommendation systems use neural networks to analyze your preferences and predict what you might like next. By learning from your behavior and the behavior of others, these systems deliver personalized experiences that keep you engaged. What sets deep learning apart from traditional machine learning? The main difference is that deep learning can automatically extract features from raw data, while traditional methods often require manual feature engineering. Deep learning models can handle unstructured data like images, audio, and text, making them more versatile and powerful for complex tasks. Deep learning can be used in both supervised and unsupervised learning scenarios. In supervised learning, the model is trained on labeled data, meaning each example has a correct answer. In unsupervised learning, the model tries to find patterns in data without explicit labels. Both approaches have their uses, and deep learning has proven effective in both settings. Convolutional neural networks, or CNNs, are a special type of deep learning model designed for processing grid-like data, such as images. CNNs use convolutional layers to automatically detect features like edges, textures, and shapes. They're the backbone of most modern image recognition systems and have achieved remarkable accuracy in tasks like object detection and facial recognition. Recurrent neural networks, or RNNs, are designed to handle sequential data, like time series or language. Unlike traditional neural networks, RNNs have loops that allow information to persist, making them ideal for tasks where context and order matter. They're widely used in speech recognition, language modeling, and even music generation. Generative adversarial networks, or GANs, are a fascinating type of deep learning model. They consist of two networks, a generator and a discriminator, that compete against each other. The generator tries to create realistic data, while the discriminator tries to tell real from fake. This competition leads to the creation of incredibly realistic images, videos, and even music. Transfer learning is a powerful technique in deep learning. Instead of training a model from scratch, you start with a pre-trained model and fine-tune it for your specific task. This approach saves time and resources, and it's especially useful when you have limited data. Transfer learning has enabled rapid progress in fields like medical imaging and language translation. Deep learning thrives on big data. The more data a model has, the better it can learn and generalize. Large datasets allow deep networks to discover subtle patterns and make accurate predictions. This is why industries with access to massive amounts of data, like tech and healthcare, have seen such rapid advancements in AI. Powerful hardware is essential for deep learning. Training deep networks requires immense computational resources. Graphics processing units, GPUs, and specialized chips like TPUs accelerate the training process, making it possible to build larger and more complex models. Advances in hardware have been a key driver of deep learning's recent success. Despite its power, deep learning faces challenges. One major issue is data quality. If the training data is biased or incomplete, the model's predictions can be flawed. Addressing bias and ensuring diverse, representative data is crucial for building fair and reliable AI systems. Another challenge is interpretability. Deep learning models are often described as black boxes because it's hard to understand how they make decisions. Researchers are working on methods to make these models more transparent, so we can trust and verify their outputs, especially in critical applications like healthcare and finance. Deep learning models can be expensive to train and run. They require significant computational power and energy, which can be a barrier for smaller organizations. Researchers are developing more efficient algorithms and hardware to reduce these costs and make deep learning accessible to more people. Ethical considerations are becoming increasingly important in deep learning. Issues like privacy, bias, and accountability must be addressed to ensure AI benefits everyone. Developers and organizations are working to create guidelines and frameworks that promote responsible AI development and use. The future of deep learning is bright. As technology advances, we can expect even more powerful models, new applications, and greater integration into our daily lives. From personalized medicine to smarter cities, deep learning will continue to shape the world in exciting ways. You might not realize it, but deep learning is already a part of your everyday life. From voice assistants and recommendation engines to spam filters and photo organization, deep learning quietly powers many of the digital tools you use daily. Its influence will only grow as technology continues to evolve. Deep learning isn't just about numbers and data, it's also fueling creativity. Artists and musicians are using AI to generate new works, from paintings to songs. Deep learning models can compose music, create art, and even write poetry, opening up new possibilities for creative expression. Scientists are leveraging deep learning to accelerate discoveries. From analyzing astronomical data to predicting protein structures, deep learning models are helping researchers tackle complex problems faster and more accurately. This technology is becoming an essential tool in scientific research across disciplines. Businesses are adopting deep learning to gain a competitive edge. From automating customer service to optimizing supply chains, deep learning models help companies make better decisions and improve efficiency. As more organizations embrace AI, deep learning will become a standard part of business operations. Education is another area being transformed by deep learning. Intelligent tutoring systems, personalized learning platforms, and automated grading tools are making education more accessible and effective. Deep learning can adapt to individual student needs, helping everyone learn at their own pace. Security systems are getting smarter with deep learning. From detecting fraud in financial transactions to identifying threats in cybersecurity, deep learning models can spot anomalies and respond quickly. This technology is helping protect individuals and organizations from evolving risks. Deep learning is being used to address environmental challenges. Models can analyze satellite images to monitor deforestation, predict weather patterns, and track wildlife populations. By providing insights into complex ecological systems, deep learning supports conservation and sustainability efforts. Robots powered by deep learning are becoming more capable and autonomous. These systems can navigate complex environments, recognize objects, and interact with people. Deep learning enables robots to learn from experience, making them adaptable to new tasks and situations. Personalization is one of deep learning's greatest strengths. Whether it's customizing your news feed, tailoring ads, or recommending products, deep learning models analyze your preferences to deliver content that's relevant to you. This creates a more engaging and satisfying user experience. Deep learning is making technology more accessible. Speech-to-text, image captioning, and real-time translation tools help people with disabilities interact with the digital world. These advances are breaking down barriers and creating more inclusive experiences for everyone. The gaming industry is embracing deep learning to create smarter, more realistic experiences. AI-powered characters can adapt to player behavior, generate new levels, and even design entire games. Deep learning is pushing the boundaries of what's possible in interactive entertainment. Finance is another sector transformed by deep learning. Models can detect fraudulent transactions, predict market trends, and automate trading. By analyzing vast amounts of financial data, deep learning helps institutions make faster, more informed decisions. Marketers are using deep learning to better understand customers and optimize campaigns. AI models analyze consumer behavior, segment audiences, and predict which messages will resonate. This leads to more effective marketing strategies and higher returns on investment. Social media platforms rely on deep learning to filter content, detect harmful posts, and recommend connections. AI models help keep platforms safe and engaging by understanding user preferences and identifying trends in real time. Logistics companies use deep learning to optimize routes, predict demand, and manage inventory. By analyzing data from shipments, traffic, and weather, AI models help ensure goods are delivered efficiently and on time. Smart cities are using deep learning to improve urban life. AI models analyze traffic patterns, monitor air quality, and manage energy use. These insights help city planners create safer, more sustainable, and more efficient urban environments. In summary, deep learning is a transformative technology that's reshaping industries and everyday life. By mimicking the way the human brain learns, deep learning models can tackle complex problems, drive innovation, and unlock new possibilities. As we continue to advance, deep learning will remain at the forefront of artificial intelligence, powering the next generation of smart technology.